few weeks ago, I was baking cookies with my daughter. This is what we are always doing. She's mixing the dough, and I'm the one who is baking the cookies. I opened the oven. I found the tray. Half of the cookies were burned. We tried to figure out, but my daughter was looking like this, her hand full of flour, and she asking me, "What went wrong, Baba?" To be honest with you, I don't know, because the recipe didn't tell me the butter was too soft, or even the oven didn't mention, do we have half of the oven hotter than the other half or not? This is what hits me, because if this is happening inside any manufacturing, what will happen? You have the data, you have the sensors are doing a notifications for your system, you have a system is recording this, you have a machines that is reporting those kind of informations, but at the end, they are always disconnected. This kind of silent moment, this is what we are trying to solve today. Today, I'm going to show you how AWS Serverless architecture, along with the Gen AI, can build a connected manufacturer integrated with an AI system to have a solid understanding of your manufacturer. My name is Mohammed Salah, working as a solution architect at AWS, looking after public sector in the Middle East. My job at AWS is helping different customers solving similar problems. Picture this. Same silence inside the factory. Machine stops, production line pause, and everyone starts running around. Every minute, your products are not made, your orders got delayed, and cost pile up. This silence, this helpless pause, what we are calling unplanned downtime. The top 500 manufacturers globally, this silence cost them 1.4 trillion US dollar every year. They are losing around 11% of their revenues. To make it much more clear, this is equivalent to the GDP of a nation like Spain. When we take a closer look about this, we found three different issues. First is the data side. Your production line consists of different machines, 4 or 5 different machines, and each machine has its own data sources or different data informations. You need to report those informations, and those informations are completely recorded in a separate database. It will end up, you have 5 machines as part of your production line. Each machine has its own database, but you don't have this kind of a correlation to understand what happened end to end. Yes, the data are there, but it is disconnected. Second is a scale gap. It's all about people. It's all about having in each factory, you will have this kind of an expert and seniors. They can understand what exactly happening on the ground. They can give you from the sound of the mixer, they can tell you there is an over mixing here. From the oven, this oven is having a problem. This is hotter in left side than the right side. This kind of knowledge, if those experts are not there, this kind of knowledge will end up that you are not able to operate your production line correctly. Because junior operators will stay in the line, receiving warnings, but they will not be able to act. This means that the knowledge are there, but are not shared. Third one, which is when this silence became visible. Because once this silence happened, the production line will get a product delayed, and the orders will get delayed. Why? Because you have a multiple data sources at the end. At the same time, you don't have this kind of an expertise that can analyze those data sources. We thought about how we can solve this. We started with a simple solution. Let's think of a data lake. As you can see here, we have a multiple data sources. We have a telemetry data and alarms. We have an environmental data, and we have a document and standard operation procedures. By implementing those data sources and having this in one data lake, we found another problem, which is the integrations. Each data source has its own integrations. As you can see, some of the data sources has a modern IoT integration, MQTT or LoRaWAN. Or even you have a legacy integrations for a document using a SFTP. What we thought about, why not to implement AWS Garnet framework to have a one single unified API to absorb these different types of integrations and convert your data in a modeled data where you can have integration between your different IoT devices in one graph database. This will build the relations between different things. Once you got this data lake, you will be able to have a different consumers for this data lake. One of them is a quick site as a dashboard, and one of them building a replica of your production line. This replica, what we are calling a digital twin. Let's have a closer look. Where you can have on the left side, this is your production line. This is what exactly happening on the ground. You understand what is the problem. As you can see, the cookie inspector is telling you cookie are cracked and the machine state is down since 5. With this dashboard, you will achieve what we are calling a connected data points. At the same time, you will break this kind of a data silos. The important part is skill gap. Yes, you have this expert, but you don't have this kind of knowledge sharing. What we thought about, why not to implement a GenAI application to be deployed over Amazon Bedrock and to let the operator integrate with this, ask a question, and chat with your data. As you can see, we are fine-tuning the model, and we are importing this model inside Amazon Bedrock to expose this kind of text and voice application. At the same time, you are getting real-time data streamed using the Garnet framework to your Bedrock engine. This will give you bridging the skill gap. Second, which is very important for the different cases, the automation needed. You need to have this kind of an automation every 5 minutes, understanding what exactly happening under the hood, know the streams, and then getting this kind of recommendations according to what's happening and what data captured from a different data sources, and give a notification to your operator to act accordingly. What we thought about, why not to have a full automation, AI, to act, to call APIs with the different machines to act accordingly. This is on a very high level how it works. You have a cookie inspector here after the former, after the tunnel, and this inspector is inspecting just in a small language model, VLM, inspecting either the cookie are cracked, or cookies misshaped, or cookies has air pockets. Let's say we're taking a cracked cookies. You are going to invoke Bedrock with a vision language model, and Bedrock will ask to get a multiple data sources. Production line, standard operation procedure, you can get machine alarms and data, you can get the telemetry data, and get even the machine manuals. Once you are getting this data source, you will be able to first send the automated notifications to your operator. At the same time, you can expose this text and voice chatting application, and accordingly, you can take actions. This is what will happen to solve the problem automatically without having a senior on the ground and without having a fully integrated data points. Here, on a high-level architecture, how it works. Let me show you in details. This is where the equipment measurements will fit inside AWS Garnet framework. And for AWS IoT Core, you will send the data using this Lambda function NSGI will change the data model of your input to a different standard data model. Accordingly, you will have an SEQS to do a decoupling between your S3, which is here acting as a data lake, to consolidate all your data points in one place. Second part, which is important here, is the actions needed. Is it possible to have actions to update actions in your production line, to update the cookie mixer, to reduce the temperature, reduce the torque, or do different actions? This can be done using an API gateway to do those actions. This is the foundational part, the data preparation. We are doing here a data preparation because we need the model itself to understand how to respond to queries. The response can be structured in a very detailed way to guide the operator how to solve the problem. Instructions should be compliant, at the same time should be safe, and should categorize this kind of a safety. That's why we thought about why not to fine-tune the model to achieve this kind of skills and this kind of tone needed for your model. We started with having a multiple documents and multiple data sources. We are transferring this to S3, and accordingly we have a step function. This step function will act as a data pipeline. You are reading the document, reading the PDF files, CSV files, text files, understanding what exactly happening on the ground, and then invoking a model to generate a structured data. Why structured data is needed? Because if you are going to fine-tune a model, you need a very structured data, because if you are not having a structured data, it's a kind of fine-tuning a hallucination machine. Accordingly, you will have an output of a structured data and another output of a structured data only for testing. This output will feed into a SageMaker AI foundation model operations, where I will fine-tune the model using this fine-tune the data and using what we are calling instructed fine-tuning. Once I got this kind of artifacts or updated weights for my model, I can accordingly import the model inside Amazon Bedrock. This step can be done in a different ways. We prefer here to use a serverless implementation by Bedrock. Instead of deploying this over an EC2 instance, will end up, you have to calculate the GPU utilizations. You have to be aware exactly what is happening under the hood to do a correct inferencing. But just importing this over Bedrock will give you a unified API to call a different versions of your imported model. Once you got this, and once you have this Amazon Bedrock, we can go to the web application. The significance here of using a web application is to expose this kind of a chatting for a voice and data with your model. As you can see, we have two different things here. First is the chatting application with a React, the normal React over S3 with the Lambda functions to invoke the model. Here we are using something called Converse API. This Converse API is giving you a flexibility and even the scalability to invoke any model versions from your fine-tuned model. Let's say you got a feedback, thumbs up, about one of your models, and this model is doing great. However, you found an issue in a production after 10 days. You can roll back in a model by just changing the model ID using the Converse API. The significance here is the Converse API remain the same signature of the API while changing a different model IDs. Second, which is the important part, is the notification part here. The notification here where you can feed the model with the data captured every 5 minutes and then start digesting those informations, comparing those informations with the fine-tuned model in order to give you a clear recommendations, considering the compliance, considering the severity, considering the needed steps to be done on the ground. By doing this, you can have an SNS notifications to your operator to notify them. You can act accordingly in this event in order to change the needed actions. At the same time, you can avail both options in the same place. This is on a very high level the architecture, where we started with digesting the information, here using a Garnet framework. And then this is the foundational part where you are doing here a data preparation and then fine-tuning the model, and then you are having a web application that connects with custom model imported over the Bedrock. At this point of time, you have an AI application that makes every single machine, sensor, and system are speaking the same language. You were able to have a connected data points and connected machines in a one single place by having a Garnet framework implementations to absorb these different types of integrations in one place. Second is you able to have this kind of fine-tuning the model, importing the model inside Amazon Bedrock, and giving you this kind of intelligence. Now you understand, you can explain what is happening on the ground, what changes, and what will done next, and what is the recommendations needed. By implementing this, you are still having and you're still generating much more data. This is what we are calling a continuous learning, and this is your goal. Once you have updated informations, you still have room to improve your model and improve your accuracy of your model and getting much more accurate information. This is what we are calling a continuous learning. This is much needed because as part of, you can see, as part of this implementation, there is a feedback implemented mechanism by the operator based on the response came from the Bedrock. If this feedback sums up or sums down, I can act accordingly and I can give updated, fine-tuned model based on this information. You can scan those QR codes. This is the Get repo for the Garnet framework to have this kind of a conversion of your connected devices. At the same time, the second QR code of how to implement a small language model and import the custom model over the Bedrock. And last one, how to continue updating your information, fine-tuning the model, and implementing machine learning pipeline end-to-end. Now, it's your turn. You can start with a small process, small data. You can understand exactly what is happening under the ground. You can start with a one production line, with a multiple data source, implement those kind of fine-tuning implementation, which is, we did this full implementation in just 7 days. After implementing this and importing the model, you will be able to gain more insights and enhance your model. Thank you.